Here I'm going to separate a mixture. It's the mixture of water and sand that we created. The tools I'm going to use, I have a plastic funnel and I have some filter papers, which are just pieces of paper, kind of like a coffee filter. They start out as round circles, and then I fold them. I'll fold it in half. I'll fold it in half again to make a cone that fits down inside the cone of the funnel. I'm going to put a beaker underneath, and then I'll take my mixture and pour it into the paper. And you can see water is dripping through the funnel into the beaker. I'm speeding it up here. Well, there's no longer any water dripping. If you look inside there, you can see the sand has stayed behind in the filter paper, and the water has gone through to the bottom, to the beaker. Let's look at a particle view of why this separation is happening. If we think about what's in the beaker, we've got like a lot of water, but the places where there's sand, it's wet sand. So we have the crystal particles, those arrangements of particles that are made of particles, and then in between them are some water particles. And then we pour it into the filter funnel, and here's what's going on at the paper level. The paper is made up of wood fibers that have gaps in between them, but the gaps are too small for one of these sand crystals to fit through. A grain of sand is just too large for the hole, so it stays behind. However, the holes are large enough that a water particle can fall through there. And so the water makes it through the paper and gets down to the bottom, and the sand doesn't. So we have complete separation with the sand staying inside the filter funnel and the water making it through to the beaker. This is all about just the differences in the properties of the material. Because it's a liquid, water has particles that are separated in a small enough size that they can fit through the holes in the funnel. Solids can't, because they're too large to fit through the holes. This filtration process would not work with the water and sugar mixture that we made. And the reason is, if we look at what's in the beaker, we have those particles that are so finely mixed that they're individual particles that can't be distinguished from each other. And if we look at the paper level, those gaps are now the right size to allow both the sugar particles and the individual water particles to pass through, because the sugar is no longer in a crystal, and those smaller particles have separated away from each other and broken up the larger grains of sugar. So all the particles would go through, and when you got down to the beaker, you would still have the same mixture and nothing would be in the funnel. By the same token, if we tried to separate our oil and water mixture using a funnel, it wouldn't work. They would reseparate to the two layers again, but as they pass through the paper, because they're both in the liquid phase, it's individual particles, and all of them could go through the paper. The sand and sugar mixture also couldn't be separated this way. And the reason is, this time, instead of both of them being able to go through the holes in the paper, neither of them can go through the holes in the paper. And so nothing ends up in the beaker, and you just end up with the whole mixture back in the funnel. Now, if you're clever, you can probably think about a way to separate the sand and the sugar mixture, because we know that the sand doesn't dissolve. Those crystals don't break up into the water and form individual particles, but the sugar will. So if we added water to our sand and sugar mixture and swirled it around and gave it enough time, the sugar crystals would break up, and then the individual sugar particles with the individual water particles would flow through the funnel, and the sand would be left behind. Now, that still leaves the problem of how do you separate the sugar back out from the water, and you may have a strategy for that as well. We'll talk about that later. Well, we said that the water and oil mixture couldn't be separated by a funnel because they're both liquids and so they would both flow through the filter paper. So here's a strategy that we can use to separate a mixture like this. Now it's a heterogeneous mixture and these two don't mix in with each other, so we can take advantage of the fact that one of them is less dense than the other one. The oil layer floats on the more dense water layer that's below. So we have this funnel here with a valve on the bottom. It's called a separatory funnel, and its whole purpose is to separate heterogeneous liquid mixtures like this one that we have right here. So the idea is you open the valve, put something underneath to catch it first, and then you let the lower layer drain, but you stop it just when you get to where the upper layer begins to fall through. So when I get just about there, I'm going to turn it off. And then if I want to catch the stuff that's on the top layer, then I just open the valve and catch the rest of it. Now this won't result in complete separation always. So you have to decide which layer you want to be more pure and either stop a little bit early if it's the lower layer you want to be pure. If you want the upper layer to be pure, you stop a little bit late. But by looking at these, you can see we had pretty good separation of the two substances. Now let's look at the problem of how do we separate the sugar water or the water and the ethanol. In a situation where the particles are so closely mixed and there are individual particles, not grains that can be filtered out, not a separate layer that could be separated out by a funnel, how can you possibly undo this mixing? Well, the process that we're going to explore here is something called distillation. This is what a distillation setup looks like. There's actually a before and after picture here. The distillation apparatus has got this container, it's just called a boiling flask. It's just a round flask that you can put some heat under to get it to start to undergo a phase change. It only has one opening, it's at the top, and that opening goes up to this tube, and you typically put either a stopper here, a cork, or you can shove in a thermometer or a temperature probe to tell what the temperature is. So this will be sealed up, and then the vapor, the gas that's created as this undergoes phase changes and begins to boil, has no place to go but here. And then it starts to progress down this tube as well. Now this tube goes inside of another tube that wraps around it. And this other tube has two openings, an inlet and an outlet. So in the bottom opening, you allow some cold water to go through, and then the cold water goes out the top opening. So that makes this section of the inside tube cold because it's in contact with that cold water on the outside. So the gas, when it goes through that cold zone, condenses and turns back into a liquid. And then that liquid drips around this pipe into this lower flask down here. So here's the idea. You've got this mixture in the boiling flask. So let's say this is ethanol and water, and the grayish particles are ethanol and the blue ones are water. You start to apply some flame here, and you start a boiling process. Now, water and ethanol don't boil at the same temperature. So there's a lower temperature than 100 degrees C where we start to get boiling occurring. And what's going on here mostly is that the water is staying behind and the ethanol is boiling. It's not quite as distinct of a flat point as if you had a heating curve for pure ethanol, but mostly what's boiling here is ethanol. So the ethanol goes up here, goes down the tube, condenses, and then drips into the little flask down here. So in this flask, what we have is mostly ethanol. Once in a while, a water particle will stick to an ethanol, and it will come across there. So you still do have a little bit of water in there. It's not complete separation, but mostly it's ethanol. At the point where most of the ethanol has boiled out of here, the temperature begins to rise, and it goes up to the boiling point of water. And at that point, you want to take this lower flask away because you've got as complete a separation as you're going to get. What's left behind after the boiling process is mostly water with maybe a little bit of ethanol still left behind. So that's a way that you can separate this mixture out. This is called distillation, and this is called a distillation apparatus. We'll take a look at that live. In this video, I'm going to take a mixture. It's a homogeneous mixture. It's ethanol and water. Ethanol is a type of alcohol. It mixes thoroughly in water. And I'm going to be using distillation as a way of separating this mixture. So I'm pouring my mixture into the hot end of a distillation apparatus. And I have assembled this whole thing ahead of time according to the instructions in a different video. I'm now inserting a temperature probe, and I'm going to put this probe above the liquid quite a ways, so it's going to lag a little bit behind the temperature of the actual liquid, but it'll give the temperature of the vapor above the liquid. Turning on the water, and now you can see the water jacket around the condenser beginning to fill up. So that'll cool off the condenser tube that runs inside there and cause condensation of the liquid that boils off the large flask. I've lit my burner now, and I'm adjusting the flame to give it kind of a cool flame. Don't want to get too aggressive there. And I'm plotting the temperature on my laptop and recording the screen as I go. So now we're beginning to see a little bit of movement. If you can look carefully, you can see the water beginning to move a little bit from energy heating. So here's the screen. Zooming in on the screen, you can see that the starting temperature is just a little above 20 degrees. That's a room temperature, approximately. And now I've moved the graph off to the corner, and we'll watch the distillation. Now this takes a while, and so it's going to be a lot of just watching water boil, basically, but I'm going to speed it up. You can see there's a rapid rise in temperature going on. This is boiling starting to take place. Back to normal speed. You can see that there's a liquid dripping now into the cold end of the apparatus, and that liquid should be whatever boils at the lower temperature of this mixture. So water and the mixture is boiling. The vapor is going up into that little Y-shaped piece. It's being forced down the condenser because there's no place else to go, and then it condenses and it shows up as liquid on the other side. You can see now that there's a flat spot developing on the graph. That indicates that we're primarily undergoing a phase change with the energy that's being added, although it's not quite as sharp now as it would be if this was a pure substance that was vaporizing. We can see that the flat spot is at around 80 degrees, so that's not water, so that must be the boiling point, or approximately the boiling point of the ethanol that is in this mixture. So back to boiling, and I've sped this way up. You can see that the level in the cold end of the apparatus is getting higher as it continues to boil. And now we don't have quite so much of a flat spot anymore. Temperature is beginning to creep up as some of the energy is now being used to increase the temperature of the water while the alcohol continues to boil. Now the alcohol appears to have completely stopped boiling because the temperature is beginning to shoot up kind of rapidly at this point. So, and you can see that the dripping has decreased a lot in the cold end. So I'm going to take this opportunity to disconnect the cold end flask, because I think the next thing that will happen is I'll begin to start having water condense in my condenser tube, and I'm trying to accomplish a separation of this mixture, and that would sort of defeat the purpose. I'm just kind of setting that in place, and you can't see it, but I'm putting a beaker underneath the output from the condenser. So this flask should now contain, I think, alcohol, ethanol, or fairly close to pure ethanol. Temperature continues to rise as it continues to boil here, and again we're starting to see it gradually achieve another flat spot on the graph. Again, you can't see it, it's off the screen, but there's a beaker catching what's dripping out of the condenser right now. Another close-up. Now we can see that the flat spot is occurring right around 100, which indicates that now we don't really have any alcohol left in the boiling flask anymore, and we are just boiling water at this point. So what's coming across the condenser and dripping into the beaker that I've put in place is probably now water, or very nearly pure water. We'll do a test to be sure. At this point, I'm going to stop the distillation process because I think separation is probably pretty complete. So I've turned off the burner. And now let's focus in on these two watch glasses that I put on the table here. So these are just kind of shallow dishes. And I'm going to take the liquid that was coming out at the end there, that fell into this beaker, and pour that on one of the watch glasses, which I suspect is water, or nearly water. And this is the stuff that was in the output flask before I stopped the distillation, which I suspect was ethanol, and it is because it lights. Now let's see if the other substance will light. And I put my match right down there, nothing happens. In fact, I can just drop the match right in there and it would never light on fire. So this distillation worked. It separated the ethanol from the water effectively by making use of the fact that they have boiling points that are quite different. So the ethanol all boiled, and then after that was condensed and boiled, the water began to boil later.